Inverse of a square matrix. If A is a square matrix of order n, if there exists another square matrix of order n, the another square matrix B of order n such that AB is equal to BA is equal to IN, where n is the order of matrix, then B is called inverse of A. So B is equal to A inverse. This is the notation of इनवर्स ऑफ मैट्रिक्स ए इनवर्स. ए के ऊपर -1 लिखना है, मतलब ए इनवर्स वी रीड एज इनवर्स ऑफ ए. रिमेंबर, ओनली स्क्वायर मैट्रिक्स possess inverse of matrix. A rectangular matrix cannot possess inverse. Now we know that A into adjoint A is equal to determinant A into I. If we divide this result by determinant A, so divide by this result determinant A cancel हो जाएगा. Now this result can be written as A into 1 by determinant A into adjoint A is equal to IN. By definition, AB is equal to BA is equal to IN, so then B is equal to A inverse. Now AB is equal to I, so we put the value of B, A inverse, so A into A inverse is equal to I. So compare this result with A into A inverse is equal to I. So देखिए, this is A, this A, so this term is A inverse, so A inverse is equal to 1 upon determinant A into adjoint A, the result number 1. So formula for A inverse is 1 upon determinant A into adjoint A. Now result number 2, inverse of every square matrix if it exists is unique. किसी भी स्क्वायर मैट्रिक्स का इनवर्स अगर एग्जिस्ट हुआ तो यूनिक होगा. यूनिक मतलब वन एंड ओनली वन. ए मैट्रिक्स हैज वन एंड ओनली वन इनवर्स. सो लेट मान लेते हैं कि ए मैट्रिक्स ए हैज टू इनवर्स बी एंड सी. Now B is inverse of A, by definition AB is equal to BA is equal to I. If C is inverse of A, so by definition AC is equal to CA is equal to I. Because all three matrices A, B, C are square matrix, so their product CAB is defined. So CAB can be written as C into AB, or AB is equal to IA, so we put AB is equal to I, so C into I is equal to C. Now CAB can be written as CA into B. We make group CA is equal to I because C is inverse of A, so AC is equal to CA is equal to I, so we put I in place of CA, so CAB is equal to I into B, this is equal to B. So from equation first and second, CAB is equal to C, CAB is equal to B, so from these two equations we can say that B is equal to C. Now we have assumed two inverse B and C, but these two inverse are equal, so we can say that inverse of every square matrix is unique. Now the next result number 3, if A and B are two non-zero matrices of same order, if A and B are two non-zero matrices of same order, then inverse of AB is equal to B inverse into A inverse. Result number 4, if A, B and C are square matrices of order n and determinant A not equal to 0. Determinant A not equal to 0 means A is non-singular matrix, means A is invertible. Invertible means inverse of matrix A is exist. तो किसी भी मैट्रिक्स का इनवर्स एग्जिस्ट कब होगा? जब मैट्रिक्स इज नॉन सिंगुलर, डेटर्मिनेंट ए नॉट इक्वल टू 0, देन ए बी इज इक्वल टू ए सी. दिस इंप्लाइज दैट बी इज इक्वल टू सी. फ्रॉम लेफ्ट कैंसिलेशन ए कैंसिल, सो बी इज इक्वल टू सी. बी ए इज इक्वल टू बी ए इज इक्वल टू सी ए, सो राइट कैंसिलेशन से ए कैंसिल होगा, सो बी इज इक्वल टू सी. नाउ रिजल्ट नंबर 5, इफ डेटर्मिनेंट ए not equal to 0, then inverse of A transpose is equal to transpose of A inverse. Result number 6, if determinant A not equal to 0, then determinant of A inverse is equal to inverse of determinant A. Now we take an example how we find the inverse of a matrix. So I take an example, let a matrix A 3, 5, 2, 7, find A inverse. वी नो दैट ए इनवर्स इज 1 अपॉन डेटर्मिनेंट ए इंटू एडजॉइंट ए. सो इनवर्स निकालने के लिए हमें दो टर्म निकालनी होंगी, एक तो डेटर्मिनेंट ए निकालना होगा और दूसरा एडजॉइंट ए. तो फर्स्ट वी फाइंड डेटर्मिनेंट ए. तो वी मेक डेटर्मिनेंट ऑफ दिस मैट्रिक्स 3 5 2 7. On calculating 3 into 7 21 minus 5 into 2 10. This is equal to 11. So determinant A is 11. Now we find adjoint of this matrix. So adjoint क्या होता है? Transpose of cofactor matrix. So first we find the cofactor of this matrix. So capital A11 is cofactor of element 3. So we hide 3 in row and column. So we get 7. So minus 1 raised to power 1 plus 1 into 7. We get 7. Now A12, capital A12 means cofactor of element 5. So we hide 5 in row and column. We get 2. So minus 1 raised to power 1 plus 2 into 2. This is equal to minus 2. Now we find cofactor of A21. A21 is cofactor of element 2. We hide 2 in row and column, so we get 5. So minus 1 raised to power 2 plus 1 into 5. This is equal to minus 5. A22 cofactor of element 7. So we hide 7 in row and columns. We get 3 minus 1 raised to power 2 plus 2 into 3. This is equal to 3. Now adjoint of matrix A. Transpose of cofactor matrix. Capital A11, capital A12, capital A21, capital A22. The transpose A11 is 7, A12 minus 2, 21 5, sorry minus 5. Now change row into column. The first row change into first column 7 minus 2, second row change into second column minus 5 3. So this is the adjoint of this matrix. Now finally we find A inverse. So now A inverse of A 1 upon determinant A into adjoint A. 1 upon determinant A is 11 into adjoint A is 7 minus 5 minus 2 3. This is inverse of matrix A.